Once upon a time, there was a TDM world. This was really a monolithic approach. Everything was together in one box. They were really hardware dependent. They were really line card, trunk card, and there was really a plethora of signaling and media control protocols. I just mentioned a few of them. R2, CAS, VSDN, ISUP. And most of the things is that it was really customized per country and per operators. There was a very limited processing throughput. I remember when I started designing on a firmware design for a board called digital signal processing, I was working in a board with 8 megahertz processing throughput. But of course, one of the good things of the old TDM that was connection oriented, and this was leading on an excellent quality of services. Most of the things here that I want to mention, there was also a lot of supplementary services. Operators try to gain on ARPU inventing supplementary services. Every operator also invented his own supplementary service in order to capture new customers. I remember in the Belgium Packet 8, was a kind of 150, almost 200 supplementary services. Of this, only 20, more or less, were really used. But then came the revolution. The IP world. At the beginning, there was only data, IP, but was connectionless by nature. But then there was processing throughput, transmission bandwidth start to increase exponentially. And method to provide a connection-oriented structure to a connectionless network, like the MPLS introduction, and method to provide a transmission priority surely for the real-time services, like diff-serve tagging, were invented. Then the voice over packet became a reality. Due to this new structure, IP-oriented, where there is a self-routing, more or less, and peer-to-peer approach, then they will start to think why we don't change that monolithic approach, why we don't get another structure. And then, if I remember well, was a soft switch forum that start to think about this layered structure. So there was really a split on the access and transport layer, on media layer, on control layer, and at the network service layer. By doing this, they open the way in the industry to have other players in the different layer. They start to be vendors for CPE, vendors for gateway, and sorry. Vendors for gateways, and of course, vendors in the control layer. I put on purpose that box that at that time somebody called the call server, other one called soft switch, but in other one there was called gatekeeper or H323 gatekeeper. I put this box called server soft switch between the two layers, control layer, network service layer, because at that time, I talk about beginning of 2000, there was not really, man, when I touch, okay. At that time, there was not a really standardized interface between the network service layer and the control layer. And for this, the vendors of this call server, they implement basically the application, the services inside the same box. And Alcatel was one of these. Basically, our product at that time was called the MGC controller or call server. We had an advantage among other competitors due to the architecture of our System 12. System 12 was a distributed architecture, which each board was really implementing some specific function. We had a board for the line control, board for the trunk control, board for the call control signaling, and board for the supplementary service. Then we thought, that we should be very easy to split, to create a middleware with a connection control layer, talking Megaco or MGCP, in order to control the gateways and have a soft switch or call server. In this way, we were thinking, okay, it's a time to market. For time to market, it was very crucial because most of all the operators saw this big, a huge opportunity to go in this direction, leaving the TDM switch. But okay, the implementation was a little bit underestimated. By the way, on this concept of starting of the NGN, there were still a lot of protocol. As you see, there was MGCP, Megaco, H248, that basically these were media control protocol. There was already H323, basically invented by the ITU, that was doing media and signaling control at the same moment. And one important thing that was invented and was brought at that time was the SIP protocol. Henry Sinreich and Eric Schuriner were the inventor of the SIP, that is indeed a session initiation protocol doing control, media control, and signaling control. One important thing that was in this structure was the interfacing with the legacy network. This is still today is still a very challenging things because it's, what they want to have is always a feature parity with the existing legacy. Then arrive 3GPP. They say, okay, try to simplify. We only focus on few protocol, SIP, diameter for the database access, but we still must support some of the legacy services, and of course the regulatory service, like legal interception. One important thing that is they really split IP platform, IMS platform, and the application, And one important message that I want to give here, that everything was access independent. So whatever was the access, the call control media layer should be the same. Then we arrive to a more structured layer where everybody, all the, let's say, the standardization body, mobile, 3GPP, but also the fixed part, tie-span at that moment, concentrated on specific layer. And of course, there were 3GPP more interested to focus on the 3GPP, on the mobile part, and the tie-span for the fixed part. Of course, keep in mind the control was the same for both access. And one more important things that was defined and centralized user profile. And this was one of the big advantages. This, just to give you a view, a little bit of history. So you see, we started in 2000. 3GPP release 4 focused really on the splitting on the control and transport. Then came release 5, release 6. Then at the release 7 appears tie-span to give more standard on the fixed part. This to lead basically to this architecture. That this was really the IMS architecture, where you see the most important component is the IMS core, where we have the service, the service, the serving CSCF, call session control function, the interrogating, the proxy, the breakout control function, and the media gateway control function in order to interwork with the legacy PSTN. So we start 3GPP, basically defining everything for the mobile access. Arrive release 6 for the wireless at that moment already. Release 7 and tie-span, they start with from release 7. Focusing basically on this part that it was the access part. And one important thing that was this, as I said before, is the home subscriber services, is the centralized database. So, because like this, they started from the mobile. So indeed, in the mobile part, so you have the great advantage is the mobility. So you could move everywhere, although having one common and centralized subscriber. But also from the fixed part. At that moment, let's talk about nomadicity. So I'm here with my SIP phone, and tomorrow I go to connect to my mother-in-law, and I still connect, I can still register on the same IMS infrastructure, keeping one database. My user profile is still centralized. But how you can see, this is very, very complex architecture. So why MS? The IPs at that moment. IMS from an operator perspective, we can deploy new service faster than ever. We have this application layer, so everybody can start to develop easy services. We can have a lower CapEx because we need smaller, a few centralized soft switch. Attract third party to start to develop new services. implement blended services, and one important thing that we can still do, we can start to make really a fixed and mobile convergence. And from the user point of view, there was really a user-centric way to think. So I can have a multimedia experience, more than voice, have a single identity for multiple communication purposes. I could have my E164 number, but I can have also my email address to make my call, to receive a call, wherever I am. And customize their own communication and have a kind of virtual home environment. These were all the hypes at that moment. So from a fragmented way that we had from the TDM world, we really have a user-centric and, with one word, the fixed mobile convergence. But now, from hypes to the reality. So this, as I said, was beginning of 2000. So everybody was really excited. Was designed for the mobile. But no one of the mobile, at least till end of 2014 and 2013 and 2000. Nobody of a mobile operator really deployed IMS. Why? Was they saw it's very complex, very difficult to operate. And only fixed operators really deployed IMS. But anyhow, another point, very important, they offered only voice services. So IP multimedia, no, they just made voice, only voice. So far, all this potential opportunity given by IMS, fixed mobile convergence, multimedia user-centric, promised by IMS, have not really reached. Then we arrive here with another attempt to achieve this fixed mobile convergence, to provide this user-centric, is what's called VoIP. But basically, you can see that I don't have a point. So this is really the innovation, is the LTE structure. It's an access. It's just another access. Now, on this access, as I showed before, the IMS or NGN should be access independent. So I use, at least VoLTE at the moment, is providing, say, VoLTE must be over IMS. There are a lot of reasons to do, I will say later. But this mainly what I want to say, that LTE is the access part. And then I put the voice, or I put another media. I can put video. But in the meantime, the other OTT, they don't stay on the bench. I just saw Google start a project called FI. Use new technology to give you fast speed in more place and better connection to Wi-Fi. Get access to multiple 4G LTE networks. Possibility to connect more tower and get fast speed. WhatsApp, again, the same story. Introducing voice calling on 4G. So what is this? It's also a VoLTE, in my opinion. Skype, same story. And today, most of this OTT, they provide not only voice, but they provide voice and video. So I make video call very easy, and I use LTE. Even I can use a 3G is working fine. So let's say what is now. From the what's the telco VoIP fans say? VoIP use the quality of services. It's more or less guaranteed the services. There, the reply from OTT is yes, correct. Although the quality services is already inherent in the LTE infrastructure. VoIP is more efficient in bandwidth consumption than OTT. Indeed, using packet header compression, but already this user packet compression is inherent in the LTE infrastructure. But VoIP is a native service. The client is on the smartphone. Why? The other OTT, they don't have their application on the smartphone. And we can have a graceful voice continuity when leaving LTE coverage. Yes, this is correct. Indeed, the OTT, they cannot do circuit switching fallback. But then the answer of the OTT fans is, so what? The mobile operator must provide a decent data service already. Otherwise, they are not competitive. If there is a decent data service, then OTT also can work reasonably well. And most of the things is that another very important aspect, that OTT, you realize that it is free. And I think that is very important. I finish.
Okay, thank you, Fabio. So on my side, you have, let's say, a message which is, okay, is IMS the future? Maybe will they win against OTT? I will show you that, IMS is today, you cannot avoid it, especially for traditional operators. So this slide is to show how many subscribers are today on IMS. So this is far to be negligible. We are in 2014, 2015. So you saw that in 2014 there were 387 million subscribers on IMS. It's planned to have something like 700 million in 2018. You see here the number of operators who have adopted IMS. So this is only known operator from the classical market studies. A little bit surprising, at least for me, when I have seen these figures, is the majority of the subscribers are in APAC. That's due to the Chinese market, without any doubt. But it's quite huge. 50% of the subscribers in Asia Pac. That's significant. So just the message here is, okay, yes, OTT is taking some big share in this voice market, voice and multimedia, but IMS is also very, very important. What are the key players for providing IMS equipment and solution? The key players, the leader is also from far Huawei, 25% market share in 2014. Alcatel-Lucent is second with 15%. And then we have Nokia and Ericsson, and Nokia. The other here, Genban, Oracle, Broadsoft, Mavenir, etc., are niche players. I would say that niche players, they are especially focused on or more specialized on either the application or the access, etc. So while Huawei, Alu, Ericsson, Nokia are providing end-to-end global solution. So we can say here is a slide extracted from the company marketing presentation. We are indeed a heavyweight in the IMS. We are number 2. This is not a peanuts market, as you can see, 3.5 billion in 2014, and we are number 2 in this market. Where are we strong? Traditionally, the market analysis make a distinction between 3 areas. The call control, that Fabio has presented, is the core. The application server, which gives all the service, the TAS, telephony application server, and then the access, SBC. There is a fourth one, which is not mentioned here, which is the database, the HSS, which is generally coupled as well with the mobile database, with the HLR, which is not mentioned here. But you see as well here, the top figures, the top picture pie charts are the market position the fourth quarter of 2014, while the bottom are over the year. So we are number 4 over the year for the control, but very close. Everybody is very close of each other. The 4 leaders I have spoken about. We are well positioned as well for the application server, but the dominant is clearly Huawei here. And also remarkable, we have now a significant market share in the access, while we were nowhere in the past. So if you look here, the figure, we were up 14 million. We have now 25 million sessions on the deployed in the market, and we grow up 14 million over 1 year. So the leader in the past was Oracle. Oracle has purchased the leader of the past, which was Acme, but the market share of Acme Oracle is fastly decreasing. So they still have 25%, but previously they were at more than 50%. So again, to say you that Alu is an important player, we have 69 active commercial deployment. And you see here the number of subscribers, the number of voltage subscribers, the number of license, the number of capacity in call control. So this is an important business for Alu. That's the message I want to deliver here. Now, a few words about what we do for Proximus Belgacom. So I will not analyze this table, which gives you a few figures extracted from the annual report, financial report of Proximus. I started in 2008 in 2014. Why? Because in 2008 we have started our IMS project for Belgacom. And the IMS program for Belgacom focused exclusively on fixed voice. So the ALU IMS program for Belgacom focused exclusively on fixed voice. And this is, in this red ellipse here, the number of lines, of fixed lines at Belgacom. And you see it's decreasing every year over year, and at a constant rate, I would say. So this is something, when we started the program, there were still over 3.7 million lines, and now there are only 2.8 million lines. So that's an important fact, but still important, but okay. This is compensated by the increase in the mobile, as you can see, and also for Belgacom business, has nothing to do with IMS, but TV is also very important. Okay, so we address with our IMS solution the red circles. And why is Belgacom moving to IMS? So this is a slide that I have picked from Belgacom presentation, and they take the same slogan as Fabio has taken. So we want all over IP, which is true. They want an IP infrastructure. They want modern technology, VDSL, etc. They want to have fixed and mobile convergence, be ready for customer, more flexible, blah, 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 blah. But this is a little bit marketing, I would say, because the key and the key point for Belgacom to go for the IMS is the second bullet here, almost building-less network. So as I have shown in the previous slide, the infrastructure of Belgacom is enormous. More than 1,000 technical buildings, hundreds of thousands of kilometers of cables, street cabinets, tens of thousands. So this costs a lot, and they want to reduce that because Fabio did not put too much emphasis on that. So TDM was nice, but highly distributed. You have, I will not say almost in every village, but in every big city or more or less city in each area of the country, you had a switch with a technical building. And so the IMS, with the IMS, you have not that anymore. It's much more centralized. So currently the IMS architecture of Belgacom, you have two control sites, one in Brussels and the other in Mechelen. While for the TDM network, it's spread all over Belgium. Okay, so the main rationale and the key, the trigger for Belgacom, for Proximus to go for IMS is this, selling their technical building. And they are buildings which are, for example, Wetstraat in Brussels, that they have sold. There was a big switch there. You can imagine a big building there, how much it brings as revenue to Belgacom when they sell it to make a parking or an hotel. I think it will be an hotel, this building in Wetstraat. So that's the key point. So now if we look at what we have done for Proximus, it has been a long run. You have to be a marathon man to work on this project. So we start in 2008, and there was almost a delivery every year. So each ellipse here with a year, it's end of the year, and this is the achievement we have done. So we have started by deploying IP Centrex, which was, Fabio spoke about the NGN architecture in the middle of his presentation. He said Belgacom as well at that time went first to an NGN architecture. And one of the, with Italtel, yes. And one of the first applications they implemented on this NGN was IP Centrex. So IP Centrex is a way to provide a sort of virtual PBX, but network-based. And it was based on Italtel plus BroadSoft. So, and first application that Belgacom asked us to move to IMS was this IP Centrex. That's what we did in 2009. Then in 2010, we had residential VoIP. So VoIP, voice over IP based on you connect an IP phone to your B box, so to your modem at home, and you can call based on that. So they had also something based on Italtel. We had to replace it. And we have made a first trial, a proof of concept of the PSTN emulation. What is PSTN emulation compared to voice over IP? By PSTN emulation, you keep your old, let's say, POTS phone, black phone. You don't change any connection, and behind that, the network is transformed, handles the same service transparently for you. This is PSTN emulation, but it is over IMS. So behind the scene, we replace all the TDM switches and so on by IMS architecture for the user, transparent, nothing changed. That's the objective. So we made the first trial in 2010, and then in 2011, business trunking, which is providing voice over IP, but for corporate customers. So basically, IP-PBX interconnection over IMS. And then after that, we have implemented the real, not only a proof of concept, but the real PSTN emulation, ISDN simulation, ISDN BA simulation, and we have deployed this architecture, which was still in a mono site, in a dual site geo-redundant architecture. You will remark that during all this period, the number of subscribers here was stagnating around 100,000, not less than 200,000. The reason was that Belgacom say, bon, the solution was starting. There were sometimes problems. There were some operational problems, let's say. And well, we had some tough meeting with the customer who say, okay, guys, you have really to improve the reliability and the resilience of your solution. Otherwise, we will never be able to deploy that on a large scale. And sorry, but it will stay at 200,000 users. So we have then made here, in 2013, a big effort, and there was some task force and some audit which were triggered. And after that, so we have transformed into a geo-redundant, And we have, that was part of this resilience program, and then Belgacom has started to migrate the user from PSTN, from TDM, to this IMS, but at a very high pace that you can see here, between, well, it was at that time 10,000 users per week, but now it's between 12 and 15,000 per week. Per week, yes. Well, in the meantime, we have continued to deliver new application, and we are now in the delivery of the support of IZN PRA, and finally to achieve the cycle and to replace completely the TDM infrastructure, we are now working on the replacement of the transit class 4 network, so TDM based, towards an IP interconnect solution. So this will be, let's say, for the fixed aspect, the end of the journey, because after that, we have replaced completely the TDM infrastructure by IP-based IMS infrastructure. And the number of subscribers remains to keep growing. We are now at more than 1.6 million, and we have, as you have seen, 2.8 million, maybe a little bit less in a few years, but 2.8 million to transfer. Okay, I will finish by giving a few challenges of this program. I see three big challenges, sorry. First, the planning, as you can have seen in this curve. Well, you must be a marathon man, but also you must go very fast, so which is, you must run fast, because we have a lot of things to do, and we have a lot of things to do in parallel. So I will not detail that, but in parallel, we have to do platform evolution, new feature, and growth. Growth meaning that you have to provide more capacity, more license, more servers, etc., for serving all these subscribers. Second point that Fabio has highlighted a little bit, but here is very important. What Belgacom expect, what Proximus expect, is complete feature parity with what they had before. So as I have said, with PSTN emulation, the user behind his phone must not notice anything. And probably some of you here are already on IMS, but you don't know. For example, me, I'm living in Brussels somewhere. I'm on IMS, but I asked to Belgacom, but I have not noticed anything. I've been transferred. The user is not informed about that. Huh? And but for this, they ask for full feature. And this is very difficult to achieve because, as Fabio explained, in TDM, everything was customized, tailored to specific customer by customer. Here we come with a product which is developed, product management is in the US. Most of the time, the coding is in China. So it's a worldwide product, and it's supposed to adapt to every operator. So you see the difficulty here. Proximus expects us to provide the same feature with the same service, etc., than in System 12, but based on a product which is worldwide. So that's a little bit in contradiction. And the last point, an operator like Belgacom has a very clear and very complex operational process. And again, with the introduction of this new technology, they expect to keep their existing operational process that were developed for TDM. So that's a little bit as well in contradiction. And this operational process, like for example, subscriber provisioning, charging, etc., they don't want to change that. That's very costly for them to change. So if they start to change and adapting this process to the new IMS, the operational cost reduction will be much less than expected. So just to finish and maybe to give a little space for question, what will be the future? Well, the challenge for Proximus, as I have said, IP-TDM interconnect, the subscriber growth, consolidate and stabilize the fixed IMS core, the fixed IMS in one single core, because today we have two cores. Very important deployment of VoLTE, but this is not with Alus, this is with Nokia. But okay, they are ongoing, they are going their way. But at that time they saw, okay, we are safe, we have two vendors. Bad luck, now they have only one. But for us, it gives us a very important opportunity, I think, for the next coming years. That's maybe to try to achieve finally this famous voice mobile, fixed mobile convergence, because belonging to the same company, maybe we can succeed that where it's more difficult if we will be too different. And I think for future evolution for the architecture would be a cloud-based architecture, but this is another story, maybe for another session of Lunch and Learn in September, then, Willem. Okay, voilà, this is all. I mean, a little bit fast, but time was pressing.